All right. I hope you're enjoying all of this. Uh, so the next in line is the following property. We are then talking of a chord and comparing the angle that this chord subtends at the center versus the angle that it subtends on the circumference. Right? That's the property that we will examine. In fact, the property is, just to formally make a note of it, you might want to copy this. Angle subtended by a chord at the center is twice the angle subtended by it on the circumference. That's the next property, right? Now, just to give you a pictorial understanding of what is required, if this is a chord AB, and if OB the center of the circle, then this angle is the angle subtended by the chord AB at the center. This is the angle subtended by the chord at the center. And if I took any point P on the circumference, then this is the angle subtended on the circumference. So what we want to establish is, we want to prove that the angle subtended by the chord at the center, that means angle AOB, is twice the angle that it subtends on the remaining circumference. That means if I choose any point P, then this would be twice angle APB. This is what we are set out to prove. Now, it's a very simple proposition, really. It takes no rocket science to be able to establish this. Some of you who would want to independently dwell in this idea for a while will be ready with an answer, will be ready with a proof. All right. So, in fact, what you might want to do is pause this for a few seconds and then figure out if you are doing good in it. That means pause this video if you like. You can connect O to P and then see how it goes. Extend OP if you've done that. Okay, so I'm assuming you're pausing for a while and then I'm allowing you to think for some time. All right. Ready with it then. Let's join O to P. Let's join O to P and fictitiously extend it to some point, any point D. Fictitiously extend it to any point D. Now, all right. I'm a little finicky about the diagrams that I draw. I would rather want clarity, and I'm not very good at it, but I like to be neat with things. Okay, so I'll try my level best to give you neat stuff, if not great stuff. Okay, so then I join O and P. Good. Now, in triangle OPA, that is this triangle OPA, OP is OA. Why is that the case? Obviously, if they are radii of the same circle, that's why OP is OA. And therefore, this is an isosceles triangle. So if OP is OA, then the angles opposite to equal sides must be equal, right? That means this angle must be equal to this angle. That means if I choose to call this angle alpha, then this angle must also be alpha. If this angle is alpha, this angle is also alpha, right? Now, what is this angle? Angle AOD, that is. the inner triangle, the exterior angle is sum of two interior opposite angles. A property, I hope you have not forgotten. In a triangle, the exterior angle is sum of two interior opposite angles. So angle AOD, do you realize is this and this sum of two interior opposite angles. So it's twice alpha. How about it? The exterior angle is sum of two interior opposite angles. So it's going to be alpha plus alpha. That makes it 2 alpha. Similarly, look at this angle, angle BOD. And that is out of triangle OPB, in triangle OPB. Let me look at some things about triangle OPB. In triangle OPB, again, would you mind believing that OP is OB? And if OP is OB, why is that the case? Obviously, they are meant to be radii of the same circle. This triangle OPB then is isosceles. And if it is isosceles, then can I not say that this angle must be equal to this angle? Angles opposite to equal sides must be necessarily equal. Therefore, if this angle is beta, this angle is also beta. Right? OPB is an isosceles triangle. OP is equal to OB. Therefore, this angle is equal to this angle equal to beta. Very good. Now, can I say that angle BOD, the exterior angle of triangle OBP, the exterior angle of triangle OBP, that means angle BOD is sum of two interior opposite angles. That means this angle plus this angle. Angle BOD, this angle would be this angle plus this angle, sum of two interior opposite angles. So is twice beta. Twice beta. Clear? Exterior angle is sum of two interior opposite angles. And then if I add these two, angle AOD plus angle BOD, angle AOD plus angle BOD, what does this turn out to be? Twice alpha plus beta, right? But what's AOD plus BOD? That's angle AOB. AOD plus BOD is angle AOB. So which means angle AOB is twice alpha plus beta. Hey, what's alpha plus beta? Alpha plus beta is angle APB. Alpha plus beta is angle APB. So this is twice angle APB. Good. That's what we set out to prove. Angle AOB, that's the angle subtended by AB at the center of the circle. And that must be twice angle APB, which is the angle subtended on the circumference. Good for us. So angle subtended by a chord at the center is always twice the angle that it subtends on the circumference. A mighty useful property. I must tell you that we're going to use this property time and again and again. We'll float with this property. We'll kind of do everything that one does with properties. This one, extremely useful. Keep a tab on it. Make it available at the top of your cranium. Have fun, but look for more. Very shortly, we'll be coming up with a bang with one more property, all for you, at your service at all times. Just a little pause. Very shortly, back again. Bye-bye.